In today's video, we are going to discuss the use of compound interest formulas. Typically, we use compound interest formulas or the compound interest when we deal with bank accounts, how much money or how much interest is earned in your bank account or certain money accounts over a period of time. Now, after T years, the balance A is in an account with the principal P with the annual interest rate of R. Our interest rate is always a percentage, but it needs to be in decimal form. It is given by the two formulas. The first one is compounded in periods per year. So when I mean by in periods per year, I could say annually, right? Annually would mean that I would do it only one time per year. If I did semi-annually, then that means it would be 2 times per year. If I said quarterly, then quarterly would mean 4 times per year. If I said monthly, then monthly would mean 12 times per year. If I said daily, then daily would be 365.25. And the reason why we use 0.25 is because every 4 years we have a leap year, which is a quarter. So we use this formula right here if we are needing to use a compound interest and it's compounding so many times per year. Now, if we were really good, then we could use a continuous compound interest. The continuous compound interest is A equals P E to the RT. Now, we talked about this E. The E is that natural base. Okay, it equals to 2 point something, 2.71879 or something to that degree. So, but we don't need to know the exact number of it, okay? But we do need to recognize where it is on our calculator. So let's do two problems really quickly. A sum of $10,000 is invested at an annual interest rate of 7%. Find the balance in the account after 10 years subject to quarterly compounding. So I would have to ask myself, which one of those formulas would I need to use? Well, in this case, if you think about it, it's compounding so many times per year because it says it's subject to who? Quarterly compounding. So I need to use this first formula. So, what is my A? We're trying to figure out what my A is because we want to find that balance. Okay? So, what is my principal amount? My principal amount is $10,000. So, A equals to $10,000. And that'll be 1 plus, what is my interest rate? Well, I have it as 7%, but remember I need it in decimal form. So that would be 0.07. Now, how did I do that? You just move your decimal place over 2 places, and that'll give you the decimal form. Compounded in is that compounding. So that would be 4. And then it would be 4 times how many years? 10. Now I get to put this into my fancy calculator and let's see what we get. 10,000, clear, oopsies, 10,000 parentheses 1 plus point, oopsies, back it up, parentheses 0.07 divided by 4, close my parentheses, raise it to 4 times 10 will give me to the 40th power. And I end up with $220,015.97. Okay? All right. Now, if I have in my second example, it says the sum of 10,000 now is invested at an annual interest rate of 7%, I'm sorry. Find the account balance after 10 years subject to continuously compounding. So continuously compounding is this A equals PE to the RT. I call it the PERT. So if I'm using PERT, again, my principal is what we always start with, the money we want to start with. So that would be $10,000, right? A equals to $10,000. E to the, what's my interest rate? 0.07. Remember, it has to be in decimal form. And T, how many years? Is 10. Okay? So now we get to put that again back into our calculator. And let's see, we have $10,000. We have our E, which is usually second ln, and then we do 0.07 times 10, or you could put it in a 7. And we get $20,137.53, because remember, you always want to round to your nearest cent. So 20,137 and what was it? 53 cents. Okay. Now, the next question is a little bit more unorthodox because we're not talking about money, but in the simplicity of our time that we have for class, I am still going to use the same annual interest rate formula, okay? And it should still work out the same as if we we're using a different formula, okay? So it says the fox population at a certain region has an annual growth rate of 7%. In the year 2012, there were 24,700 foxes counted in the area. What is the fox population predicted to be in the year 2020, right? So round your answer to the nearest whole number. So how many are we basing this off of? We're basing this off of 24,700 foxes. So that will be my start point. Okay, that would be my P. All right. Then what is my interest rate? My interest rate at this point is 7% per year. So my rate is 0.07 and my N is 1. How did I get 1? Because it says per year. Okay, so if I plug this all into the formula, A equals to P times 1 plus R over N to the NT, right? Then this gives me 24,700, right, times 1 plus 0.07 divided by 1, right, times, or raised to the 1 times, well, we need to figure out what is the population predicted to be in 2020. So between 2012 and 2020, that would be, I'm sorry, I meant to put this up here, and my time would be 8 years. Okay. Again, T, I'm sure I did not explain it, but T has to always be in years, not months, not days. It has to be years. Only N can be in a different time. So now we get to put all of this into our calculator again. So clear it out. We have 24,700 parentheses 1 plus parentheses 0.07 divided by 1, even though we know that's the same exact number. Okay, but I'm just going to put it in here so you understand how to put it in your calculator. Raised to the 8th power. And I end up with 42,000 439 and 0.19. But if we remember, it says round your answer to the nearest whole number. So in this case, we would just have 42,439. All right. Now, that last question we have. It says to save for a new car, Zoe invested $5,000 in a savings account that earns 4.5% interest, compounded continuously. After 4 years, she wants to buy a used car for $6,000. How much money will she need to pay in addition to what is in her savings account? Round your answer to the nearest cent. So at this point, Zoe has $5,000 and she's trying to get her money up to this $6,000, right? She has a bank account that gives her quite a bit of money, quite a bit of percent, which is 4.5. The average bank account gives you 0.08%. Okay, and it's compounded continuously. So anytime we're going to deal with something that's compounding continuously, remember we use the PERT. A equals P E to the RT. So my amount that you always invest, that you start with, is your P. So my P in this case will be $5,000. E to the, what's my interest rate? 4.5%. So again, move your decimal place over 1, 2. So that means that is 0.045 as our interest rate times how many years are we talking about? After 4 years. 4 years is our T. Okay? So again, we need to use our calculator to find out how much money is in this account after 4 years. So let's clear it out. We have $5,000, right? E is, again, second LN to the, put it in parentheses if it doesn't come up, 0.045 times 4 years, and then close your parentheses, which equals to, oh, she's very close, $5,986.09. Again, remember you have to round to the nearest cent. So she has $5,986.09. But she needs $6,000 for this used car. So how much more money, it asks, how much money will she need to pay in addition to what she has in her savings account? So we would need to subtract this, okay, by $6,000. So we could say $6,000 subtracted from 5,986.09 will give us $13.91. So that's how much money she needs. $13.91 is what she needs in addition to getting to her $6,000. That's it for our video for interest formulas using word problems. If we have any questions, just let me know. Peace.